Okay, so I'm a little disappointed in myself for taking so long to get started with this, and I have 20 minutes to do this, and apparently it's a 14.5 minute read, and so I'm not going to finish it by any means, but I just have to get started because I've been saying I'm going to read this for weeks. It seems like I am streaming, which is good. I'm just going to make sure the audio is working. It's a 14.5 minute read, and we are good to go. So I'm just going to get started, to be honest. Okay, so hello everybody, and welcome to Smoothie with Chloe in the morning. So everyone's been telling me that when learning about R1CS, this is the article to read. Rank 1 constraint systems, R1CS. So I'm just going to start reading, getting into it, and when we get to the R1CS stuff, I'm just going to stop and kind of try and understand it, take notes a bit more, and from there, what's it called? Probably have to stop the stream, go to the Research DAO office hours, which is in 20 minutes, and yeah. So, quadratic arithmetic program, so QAP, from 0 to hero. Let's hope so, because right now I'm pretty close to 0, and I'm hoping to get a lot closer to hero, although this is written in 2016, so we'll see. So there's been a lot of interest lately in the technology behind ZK snarks. And people are increasingly trying to demystify something that many have come to call moon math. So in 2016, when I was hearing about this, or 2017 in 2017, I was not hearing about it in 2016. That's a total BS. In 2018, more realistic, when I was hearing about this, to me it was moon math, right? It didn't really make much sense. I started looking into it. I started realizing, okay, pieces come together, and now I'm like, okay, I see the pieces, but it still seems very moony. Due to its perceived sheer indecipherable complexity. ZK snarks are indeed quite challenging to grasp, especially due to the sheer number of moving parts that need to come together for the whole thing to work. But if we break the technology down piece by piece, then comprehending it becomes simpler. I would have to agree with that. The purpose of this post is not to serve as a full introduction to ZK snarks. It assumes as background knowledge that you know what ZK snarks are and what they do. So a ZK snark is a zero knowledge, succinct, oh gosh, it has to be like succinct, concise, not leak any data. I'm not good at memorizing what the actual snark part means. Succinct, arithmetic, yeah. Anyways, are trying to do. I'm terrible at remembering. I'm just gonna have to Google it, I think. Snark. See, it doesn't even. Oh my gosh. What comes up? No, I just want like what an actual snark. See, like maybe this is kind of the problem. Like I already know what it. There you go. Succinct, zero arithmetic, and then zero knowledge. So the K is for the zero knowledge. See, I just couldn't remember what the K was for, but what they do, yes, I know what they know enough math to be able to reason things like polynomials. See, that sounds complicated, but then this example is relatively straightforward, right? So if the statement P of x plus Q of x equals P plus Q of x, where P and Q are polynomials, seems natural and obvious to you when you're at the right level. So, I mean, I suppose so. I read enough papers for it to seem obvious to me. I will be the first to admit that I'm not amazing at math, but I mean, this stuff is relatively straightforward, just from reading papers, to be fair. Rather, the post digs deeper into the machinery behind the technology and tries to explain as well as possible the first half of the pipeline, as drawn by ZK Snark researcher Aaron Tromer here. So, computation, algebraic circuit, you break it down into a circuit, and then you have this rank 1 constraint system, which it sounds really complicated, but then when it's like, seeing an example of it written out, I'm like, oh, it actually makes sense if you see it. And then you have quadratic arithmetic programs and linear PCP and all this stuff. I'm not even taking notes yet because to me this is quite straightforward so far. So we'll see how much notes I even take today. The steps here can be broken into two halves. First, ZK snarks cannot be applied to any computational problem directly. Okay, so yeah, that seems... for me, I'm going to try and just keep this as simple as possible because, you know, I'm basic. So I'm just going to take a screenshot and I'm going to copy it to my clipboard. And then I usually like looking at a diagram first and then see, I don't like how it's written like this. Anyways. I guess I want to have that. So, oh, can I put something there? So diagram. Oops. Can I do that? Oh, how do I? I dislike this. Nope. I can do that. Fine. What? Fine. Simple enough. I don't know why it's being like this. Apparently, the steps can be broken up into halves. I am going to try and go through this a bit quicker. So usually I would type these things out, but now I'm just trying to make sure I keep track of where I am in the article so I don't waste time next time. First, you get to convert directly, rather than convert the program to the right form for the operator to operate on. So that's, I'm just going to, again, I don't have really time to, I'll go through and like take some of this out because that's way too long. Already that's going to bother me. Fine. That's like the form is called a quadratic arithmetic program. So this is, I guess. Okay. And transforming the code of a function into one of these is itself highly non-trivial. Along with the process for converting the code of a function into a QAP is another process that can be run alongside, so that if you have an input to the code, you can create a corresponding solution, sometimes called a witness to the QAP. Okay, along with the process for converting the code of a function into a QAP is another process that can run alongside it, so that you have an input to the code, so that if you have an input to the code, you can create a corresponding solution, a witness. So there's another process that runs alongside it. That can be, I guess. Can be run alongside QAP. So I guess to create a witness. Okay. After this, there's another fairly intricate process for creating the actual zero knowledge proof. For this witness. Then intricate process, oh gosh, for creating the proof with, oops, And a separate process for verifying the proof that someone else passes along to you. But the details are out of the scope for this post. Okay, cool. Okay. The example that we will choose is a simple one. So example will be a simple one. Proving that you know the solution to a cubic equation. Equation x, is that just saying like to the exponent of, okay, I don't know why it's written like that. Man, why is it written like that? Hint, the answer is 3. This problem is simple enough that the resulting QAP will not be so large as to be intimidating, but non-trivial enough that you can see all of the machinery come into play. Let's out a function as follows. Okay, so let me first write it out and like write the equation out, and I think I can just copy and paste this. Do I have to put the type of code here, or can it just no? It'll be fine. Oh, so if I write it, it'll give me highlighting, but if I just leave it, it'll be fine. Okay. So the equation is, so I was trying to just put it in between like the formatting stuff and just be like x, is it saying to the, like to, yeah, x, I think it's just saying cube rooted. So I don't know why. Like, can I write it differently, or should I feel bad writing it differently? Is that, okay, to be honest, I just feel bad writing it differently, so I'm just gonna copy and paste it so I don't have to feel bad writing it differently, and I can just write it out. See, but it wants me to write it as a proper equation. So, nope, it's my notes, so everyone can go suck it. I think they're just doing it like that because on the computer you can't do like this thing. Where's the little hat? I am tired today. That's how you do it on this one, right? There you go. And then it'll show up like that. Yeah, x cubed plus 3, no, x cubed plus x plus 5 equal to 35. You know, and it's 3. This problem is simple enough. Okay, yeah. The simple special purpose programming language that we are using here supports basic arithmetic, sorry. All these wonderful things. So, you know, special purpose language we use. My gosh. Supports basic arithmetic. So like, okay, I'm not gonna, that's gonna bother me. Let's just, I'm like so used to using that textbook where I couldn't copy and paste that I'm so used to typing everything out. That's a bad habit. Constant power exponentiation. Okay. Yeah, no loops allowed, man. Okay. You could do. I don't know why. Oh, because I think I have to backslash it to not have it do it. But can I do another one? Oh gosh. Do I have to do another one? Yeah, I think that works now. No, what? Now I can't tell what my note looks like. Is this showing or not showing? I feel like you backslash something to have it not show. Oh, Lord, help me. I could just do this around it, and then that should also solve it. Perfect. Simpler way. Okay, I do have to go. Sadly, this has actually been a great article so far. No way I'm going to get, like... I'm glad I started and got through it. I won't be able to stream the rest of the article. I'm traveling soon. Maybe later on today I could stream the rest of the article, actually. So maybe I'll try and do that. But I do have quite a few things to do for the rest of the day. But yeah, actually, you know what? I'll try and maybe pause the stream or whatever and continue to stream later. Let's see if that's even possible. Or I know it's possible, but... yeah, I'm only seeing the option to stop the stream, sadly. So I don't think I'll be able to pause. But that's alright. Honestly, I'll get the notes done at some point, which is what I really want myself. And then to listen to the article, this one is on Medium, so you can just click play. So honestly, streaming it probably isn't that useful for anyone. Myself, yes, but I like more having the intro stream, so I remember what notes were, or what papers or articles were important enough to stream. But see y'all, everyone.